Hey guys, this is Coffeeyay for HUSNG.com. Today I just want to welcome you to my Math and Heads Up Sit and Goes video pack. The purpose of this short introductory video is to help you navigate through the pack. It'll provide you with a basic approach that I use in building the pack. It'll provide you with focuses of the video pack. And it'll also provide you with an outline together with summaries of all the videos. The idea is to provide you with a sort of syllabus for this Math and Heads Up Sit and Goes course, because I think that's a good way of approaching it, is as a course. There are 10 videos of footage in addition to an introduction and conclusion video, so there's just a lot of material. It's all structured in the form of lectures, PowerPoints and lectures, and so in order to get the most out of it, it's good to have an idea of what the syllabus looks like and how to best approach it. That's why I end this introductory video with recommendations on how to get the most out of the video pack, to make sure that you're using this to improve your bottom line. So let's talk about my approach to building the pack. The idea behind the Math and Heads Up Sit and Goes pack is to give you a set of mathematical tools so that you're able to solve various problems in Heads Up Sit and Goes on your own, and so that you understand how these kind of problems can be approached by using math. We want to build up a solid foundation of poker theory so that you're able to more effectively analyze situations on your own, which will make your studying much more efficient. Not only that, but it'll also improve your in-game thinking, because as you analyze more efficiently situations out of game while studying, that'll directly impact how you're doing in-game with your in-game thinking. And so it's going to be a really important focus just to work on improving our strategic thinking. And that's, really main approach to my video pack, is to work on you improving your strategic thinking and to give you tools to improve your own strategic thinking. I want to let you connect multiple decision points and ranges together. I want you to be able to think about multi-street bluffing, think about how villains' ranges should be adapted to based on small samples, how we can be crafting exploitative strategies. Now, while the poker metagame is constantly changing, and so a video describing how to play at the hundreds can quickly go out of date, the math behind the game, behind Heads Up Sit and Goes, is not changing. And so that means that basically the same approach and the same methods that are developed in this video pack will let you solve for situations for the next many years and for many different formats of Heads Up Sit and Goes. And so the only thing you'll have to worry about is the inputs of your equations. And so the process of maximizing your expectation, the process of building these computational tools and database tools and building up your sense of the population will stay the same. And so because this is such a strong feature of math, one of the most useful things about math is its generality. I did strive to keep this pack as general as possible. That's why some of it can seem a little bit daunting at first, a little bit abstract. That's because when you learn it in the abstract general sense, you'll be able to apply it to your specific needs. When you learn the hard big version, the small easy examples that you have in game will be easy. But if you just learn, how to solve one little tiny part of Heads Up Sit and Goes, and suddenly you're trying to use this for PLO Heads Up Sit and Goes, or for turbo speeds rather than hypers, or something like that, you'll end up with troubles. And so that's why, while my focus as a player is hyperturbos, and so many of the examples are specifically hyperturbo based, overall you can think of them as just being end game turbos, for instance, examples. And overall, all of these methods that are built up can be used in every other form of Heads Up Sit and Go. So let's quickly go through the focuses of the pack so that you know what you should be thinking about and what will be clarified throughout the pack. One of the major ideas is just being able to find ranges that maximally exploit our villain's ranges. That's always the goal of poker. It's putting our villain on ranges and exploiting those ranges. And so, once we've put our villain on our range, how do we maximally exploit that? How do we maximize our equity? How can we try to, adjust our decision-making to take into account villain's ranges? And so one of the major focuses, of course, is going to be learning computational methods to be able to answer that question. And the major tool that I'm going to use is break-even frequencies. Those will give you frequencies at which actions are better than some other binary decision. in the video pack, that'll usually be folding. So it'll give you frequencies for which you're better, or you're break even or better to take an action other than folding. And that'll let you build up your strategy by avoiding unnecessary folds. By comparing to a constant, which is folding, we'll have methods for being able to compare our decisions and make the best decisions at every decision point. Now, another of the major focuses is just developing methods to analyze the population. Now, you hear a lot of talk about the population tendencies and things like that. And a lot of people say population tendencies, but they haven't really studied them themselves. The idea is that, if we actually go through and study the population and treat the population sort of like a model villain and build ranges that exploit that model villain, that's how we get very, very profitable readless strategies. That's how we get readless, maximally exploitive ranges, because we maximally exploit the population. In order to do that, we have to develop methods to analyze the population. We're also going to be working on computing Bayesian estimators. Bayesian estimators, very quickly give you an idea of how quickly to adjust and, what size adjustments to be considering. And they let you use very small samples to adjust to villain behavior. They also end up strengthening our sense of the population tendencies as well, because they're Bayesian, they're actually built from the population tendencies. And so they allow us to think about making adjustments as moving our readless ranges away from being readless, as sort of changing our population into a small subset of the population that includes our villain, or sort of centered around our villain, or our villain's small samples size. Throughout it, a focus is going to be just grounding all this poker theory in specific examples. Again, because of the scope and generality of this pack, many times things will seem abstract. And so I've made every attempt possible to include as many specific examples from poker, from heads up, sit and goes as possible. So when talking about these break-even frequencies, I compute a lot of them for many situations you face in the game. For developing methods to analyze the population, I develop methods to do so and show you ways to do further analysis on your own. In showing you how to compute these Bayesian estimators, I also compute some of them for you. Now, the things to keep in mind are the examples in the pack are intended to help you learn computational skills and enable you to solve similar problems on your own. They're not the main purpose of the pack. So if you're considering, buying this pack just so that you can play chart poker, just so you can, take all the charts from my video pack and solve, and have the solution of poker, or just immediately start crushing whatever stakes you're playing, that's not going to happen. You're going to have to put in the work yourself. But I give you the examples so that you're able to put in that work yourself efficiently and without confusion. And so, again, work out these examples yourself too. Just because I work them out doesn't mean I've worked them out to full detail, doesn't mean I've done every last part. There's always more to be done. And one of the major ways I'm going to ground this theory is by building small blind push-fold strategies. And so, I just said that, don't expect to get charts to be able to immediately profit. Well, I was lying a little bit, because the charts that I built for small blind are basically charts that you can use just to profit. They're going to be readless ranges combined with Bayesian adapted ranges. So it's going to so that small blind push fold section is going to talk about how to put together all of the tools that we made into solving sort of a bigger specific example. And I will give you ranges for shoving, and I'll also give you the process of adjustment and ranges to use when adjusting to our villain, and how to make that whole thing Bayesian. In addition to talking about some of the other popular strategies for push-fold, obviously I'm going to be talking about Nash. Obviously, Nash is going to be a focus throughout the second half of this video pack. Once we've introduced game theory, we can't get away from Nash equilibriums. I'll also talk about some of the other push-fold charts out there, Sklansky, Chubukov, Sage, but those don't matter. What's important is building up the sense of being able to build ranges and fully exploit them. And so in that small blind push fold, I'm going to build readless ranges. That is, I'm going to build a population maximally exploit it to give us ranges that are maximally exploitive readless ranges for small blind, for short stacked small blind push fold. All right, so let's just dive in and talk about the outline. So one thing about this video pack is I've been working on it for a long time. And so I started it back in, May? I started this video pack in May, and some of the videos were posted on HUSNG.com as part of the standard membership. But there's no way they could not be included in this video pack. They're just fundamental first stepping stones to building up our theory. And so I started out back then with some videos on basic computation. Part one of the series it has a little bit of an introduction as well. It's an older introduction, so that's why I'm adding this introductory video. But it specifically talks about introducing you to the equity equation, to being able to build an equation for our equity, and talking about how maximizing that equation is our goal in poker. And we're also going to be talking about calculating pot equity. That's the special example. That's sort of the case I solved in that part one, is just calculating pot equity needed to call shoves. I don't call it that in the video because I'm trying to do it in generality. I'm trying to show you how pot equity is just simply maximizing expectation, and how those are actually one and the same. In part two, I add in fold equity. And so I'm going to establish this approximation method that I use throughout the computational tools called a pure fold equity approximation. And I'm going to use this approximation to find some frequencies for which we, if we want to look at bluffing pre-flop and post-flop. So that'll give us that approximation that's needed to figure out some basic bluffing frequencies. Continuing on with computation, in part three, I worked on combining pot equity with fold equity. Specifically, I looked at shoving over bets. And in part three, I work out a lot of stuff about check raise shoving, and comparing the amount of pot equity we need with the amount of folds, and putting those two together to figure out profitable shoves. In part 3b, I do this same thing. I combine pot equity with fold equity, but specifically for pre-flop. And I do this by using Icemizer, an advanced computational software that is available through HUSNG.com, or there's a link to it through HUSNG.com. And that's to specifically compute shoves pre-flop. Because pre-flop, in a sense, is even more solvable, the software can do sort of all the math for us. It makes sense to use it. And so I talk about how to use Icemizer, the ways to study with it. And I do compute some ranges for open shoving and 3-bet shoving, and look at how to examine those, how to compute those. And then in the last computational video, this is one that wasn't released on HUSNG.com. This is one that's a new one to the video pack. It's advanced computation. It's building up all these computational tools to start solving all of the hard cases. Before that, those are all easy. Those are all pretty simple examples. Advanced computation starts taking us outside of the simple examples. And specifically, we're going to be using the total equity equation to solve for situations involving multiple streets. So we need to look at how villain's flatting percent affects our bluffs. How does equity of our hand affect our bets as well? And so I present sort of a general approach and general solution to this problem. And I also build a few approximation tools to be able to look at two-barrel bluffs. That'll improve on the approximation we built in part 2, and also on semi-bluffs. We'll be looking at how equity affects how many folds we need on a semi-bluff. So that's sort of the one big chunk of the video pack is just computational tools. That's our sort of our toolbox. We need those to be able to solve for things. And so once we've established all that, then we can actually build up some development of strategies. We can actually start building strategies. We can start talking not just about decision points, but how those decision points connect with each other, and how a strategy is sort of that, the sum of all the lines we can take. And to frame that, we need some basic game theory. And so this is another video that was up on HUSNG.com. This is the last video that that was a part of the standard membership. It's basic game theory. And in this video, I just introduced key aspects of game theory. I talk about it from sort of the point of definitions and some basic theorems. There's no proving. It's pretty bare bones sort of cliffs, because it's meant to be usable by you in HUSNG.com. In HUSNG, sorry. And so I try to keep it sort of as simple and conceptual as possible, and try to give you a lot of stuff to think about. There's so much really cool game theory to think about. And so I'm just trying to like give you some launching points for your own explorations. And again, just keep you know, this kind of game theory stuff just keeps helping you with your own strategic thinking. And that's, you know, that's the major goal of these things, you know, and major focus, as I said, is just, you know, improving your strategic thinking. So that's basic game theory. I then talk about population tendencies. And, you know, population tendencies are just so fundamentally important to playing heads up, sit and goes. Because in heads up, sit and goes, you often will be playing against people who you will only play one game against. You will have some small sample against them, but you know that you're going to finish that whole game. So you always have some guaranteed sample. So we should be, you know, we get sample of every sort of villain, but we don't often get rematches. We don't often have time to build adaptive strategies. I'm sure, you know, in the grand scheme of things, we should always be looking to adjust to our opponent. But when we're playing against a random, what approach do we use? And the approach that I sort of suggest in the game theory part is that of building population tendencies and maximally exploiting them. And that's sort of an approach to readless play for me. Rather than thinking about things in a vacuum, which makes no sense, we think about them as in the population. We sort of submerge our villain, put him as just an example of that population, and figure out how to construct ranges for that player and ranges versus that player. And so the first video about this is constructing population models. I use PT4 to set up a global alias that allows us to have PT4 in a form that lets us quickly find population frequencies and ranges straight from our database. And that's going to just be an extremely powerful tool. If you're worried, you know, oh my gosh, I don't have PT4, I'm going to lose value on this. There is a method outlined for HEM and HEM2, so you won't be stuck. I work through it specifically for PT4, but the information is relevant and applicable to both HEM and HEM2. It's basically whatever database software you use, you can set up this kind of global alias. Just to be complete, I don't know how to do this for Poker Copilot, if anyone asks. I know that the Mac, one of the Mac tracking softwares is Poker Copilot. I actually used to use it. It's a decent program, but I don't know if it's possible or how to set up a global alias. You would have to try to work on that your own. But again, for PT4 and for HEM users, this will be very useful because you'll be able to set your PT up, your database software up to be able to extract ranges and frequencies directly out of it in efficient ways. And the second part of our population tendency talk is developing Bayesian statistics. Now, Bayesian statistics is a pretty, you know, overarching theme, I think, in poker, or at least should be, and especially in heads-up sit and goes. Again, because when we play heads-up sit and goes, we're often faced with small samples, but we want to make adaptations as quickly as possible because we know we're going to be playing the villain at least till the end of the game. We get stuck in sort of needing to figure out how to make these adaptations and when we should be adjusting and when is it too fast to be adjusting. And so what we're going to do is we're going to use our model of the population in order to build a Bayesian prior. We're going to sort of put a statistical distribution on the population tendencies. And what this will do is it'll allow us to use small sample sizes with maximum efficiency just to estimate deviations from the populations of our villain's frequencies. Let me say that another way. Once we have sort of an average for our population, we can start checking to see how, you know, villain's specific frequencies that we see in game move him away from that population model, move him away from those population frequencies. So if villain is opening a lot of buttons, you know, what opening range should we set him on? Because it's clear he's opening more buttons than the average player. So while readless, we had to use our average player model and exploit that. Once we get statistics, we can start adapting our model and exploiting that. And Bayesian statistics gives us that tool for making good adaptations and for thinking about how we should be making adaptations and how we should be using our sample to make them. Once we've done all that, we have all these tools. We have all these computational tools. We have ways of game theoretic thinking, and we have ways to model and work with population tendencies. I'm going to use all this stuff to solve a very specific, very big example. And it's going to be small blind push-fold poker. And we're going to use these tools to build a robust strategy to these push-fold stages of heads-up sit-and-goes. I mean, this is, again, a very heads-up sit-and-go specific task because we know the blinds will get short. So at some point in every heads-up sit-and-go, we will face endgame push-fold decisions. And maximize our expectation in those is something that actually isn't outside of the realm of the tools that were built so far on that video pack. And so the first video is going to be about maximally exploitive readless ranges. We're going to use our PT4 global alias to find at various depths this big mixed range that represents the population tendency for calling open shoves. Then we're going to use our calculation tools. We're going to use some of the tools developed in those calculation videos to just find maximally exploitive shoving ranges versus that giant mixed range. And we're going to do it at a few different depths and look at how those ranges compare to Nash. The next part is something that's even more advanced, and that's making Bayesian adaptations. So again, we're going to use that model of the population, use that model that we built using the global alias, and develop a Bayesian prior on top of it. Again, for the population calling range. We're going to look at, how can we start getting reads on villain's calling range by looking at what he's doing. And we're going to be using Bayesian statistics to develop criteria for adapting to our specific villain. As our estimator says certain things, we should make certain adaptations. And so we're going to find alternate shoving ranges that try to further exploit deviations from population tendencies. So we can start adapting that when we have reads and we have statistics that suggest that villain calls open shoves wider than average, what ranges should we be shoving? And same for tighter than average. We'll even find that as we get reads that our villain is indeed shoving average ranges, we should actually be adapting our readless strategy. Even though our readless strategy was built on the population, it was built on a very big mixed range. If we hone in and narrow down our villain to being, even more towards the sort of center, we'll also want to be adjusting our strategy. And so that video will talk about all these adjustments and how to make them and sort of what criteria we can use. And again, this is set as a specific example. And so the idea is to give you the tools and the specific example to be able to do this kind of development on your own. And to be able to, for instance, solve the same situation for big blind. That's completely in your realm once you've finished this course. You will be at the point where you can solve big blind push-fold poker the same way and look at villains' open shoving ranges the same way and use Bayesian adaptations to change our calling range. And that's the strength of this video pack, is that while I solve some stuff, if you're not interested, if you play turbos, that you'll still gain from it, but it'll give you more tools to be able to solve for other situations and for analogous situations. All right, so that's the outline. And so let me just leave you off with some recommendations for how I believe that the video pack should be approached. In the end, everyone has different learning styles. And so obviously, what I say for some people won't hold for others. However, there are things that I think will help you to get more out of the video pack, which is my goal, to get you to to get as much from the video pack, to have it help you improve your game as much as possible. And so one of the starting things is don't jump around. You should watch videos in an increasing order of complexity. So that's not to say you can't watch some of them out of order, but basically don't watch the advanced computation if you haven't watched the beginner or intermediate ones. Don't watch the Bayesian Bayesian statistics before you've watched the population tendency. Don't watch the Bayesian adaptations before you've watched for small blind push-fold before you've watched them at maximally exploitive reads. The game theory video can be watched at any point. I think that's a very nice one to watch early. And similarly, you can watch the computation videos, for instance, after the ones about the population. You can sort of move the modules around, but within a module, within computation, don't watch more difficult ones before watching easier ones, and don't watch a later video in a module before watching the early ones. Work out situations on your own to convince yourself of the math. I mean, I go through a lot of the math, but having it worked out for you and working out yourself are very different things. And being able to convince yourself that, that what you're learning is correct is incredibly important towards the learning process. And so following along with my computation, following along with my methods will help solidify the things you learn and make them more understandable. Otherwise, they can just be this, hazy thing. But one thing that I've always noticed in teaching math, and I used to teach physics, is that sometimes things take time to click. So do give yourself time, but the best way to make sure that things click quickly is by working out and following along as much as possible. One thing to always do is pay attention to all the considerations and assumptions made throughout the pack. Again, in some situations, I'm solving different special cases. If you understand what considerations there are and what assumptions I made, then you'll fully understand when and how to apply the different tools, and that's the key. I want you to not just know, how these tools work and how to compute stuff, but also when and how to apply the correct tools. And so if you're not paying attention to the considerations, the assumptions, you're not going to know how to apply them, even if you know how to compute them. One thing that I've learned in the past when working with physics students is that working with others is incredibly useful. It makes learning so much easier when you're not doing it on your own. And so, I strongly recommend talking to a coach or a study buddy if things aren't clear, if you're having trouble, if you want to just go over and make sure you're doing things the right way and make sure you're not making any mistakes on your own. Both because you might be making a mistake and it'll help you a lot to clear up mistakes, but also to give you confidence when you are doing things correctly. It'll make you feel that much better and be able to get more out of your studying. And so again, working together with others will go a long way towards furthering your understanding of the topics and even just motivating you to improve your game and maximize your potential. Because if you're just sitting there alone grinding, I mean, it's hard to get motivated to put in hours studying math and put in hours studying your game and making your game better. Even though that's what's needed to maximize your potential, to get your game up to the potential that it could be at. And so, again, though, one of the most important things throughout this is for you to put in work. This video pack will not make you an amazing player on your own. You're going to have to put in the hard work to get things out of it. The video pack is just meant to give you ways to put in that hard work, give you places to put in hard work to give you guaranteed improvements in your game. And so try to work through as many of the suggestions for further study as possible, because I've tried to make every one of those important things that will improve your game. And so these are keys to improving your game. They're not maybe all of the keys. They're not all the keys for sure. There are other ones. There are a lot of different ways to approach a game, but those are places where if you are wondering what to study, any of those are profitable things to study. So the more of those you work out, the more profitable study you're making. All right, so that's it with the introduction. Again, I recommend you begin with part one, the equity equation. That being said, if you've already watched it because you had standard membership, then I would recommend either watching the advanced computation video or the population tendency video, modeling the population. Those are my recommendations for what you should go with next. All right. Well, so good luck. I hope that you enjoy this video pack. I hope that you gain a lot out of it. I put a lot of time and love into this video pack. It's something that I'm very passionate about. I love the mathematics behind poker. It's something that I love explaining. it's just something that's always been something important to me, is learning ways to explain difficult and complex situations. It's something that I'm always striving to improve in myself. And it's something that I try to put into my video packs, into my one-on-one coaching, into my HUD and other products, is my enthusiasm and love for math. And so I hope that you get some of this appreciation too, and I hope that it helps. I am available via email. You can send me an email with any questions, concerns, etc. at coffeeyay@gmail.com, and let me know what you think. Let me know of ways I can help you, and etc.